Today we're diving into a paper that explores a novel approach to enhancing the reasoning capabilities of large language models, LLMs. The paper, Improving LLM Reasoning with Multi-Agent Tree of Thought Validator Agent, proposes a framework that combines the tree of thought strategy with a multi-agent system. Let's start with the core problem this paper addresses. What are the limitations of current LLM reasoning methods?
Current LLM reasoning methods often struggle with complex tasks that require systematic and reliable reasoning. One key limitation is the shallow exploration of reasoning paths. LLMs may not fully consider the complexity of the problem space, leading to inaccurate or incomplete solutions. Another issue is the lack of a robust validation mechanism to ensure the trustworthiness of the generated reasoning. So the paper proposes a multi-agent framework to address these limitations. Can you explain the key components of this framework? The framework consists of multiple reasoner agents and a thought validator agent. The reasoner agents employ the ToT strategy, which involves exploring diverse reasoning paths in a tree-like structure. Each reasoner agent generates a reasoning branch, representing a potential solution path. The thought validator agent then evaluates these branches, checking for logical consistency, factual accuracy, and completeness.
How does the thought validator agent work? What criteria does it use to evaluate the reasoning branches?
The thought validator agent performs a comprehensive assessment of each reasoning branch. It checks for logical consistency, ensuring that the reasoning steps follow a coherent and valid logic. It also verifies factual accuracy, ensuring that any factual claims made within the reasoning are correct. Finally, it assesses completeness, ensuring that the reasoning branch adequately addresses all aspects of the original query.
This sounds like a very thorough evaluation process. How does the framework handle the situation where multiple reasoner agents produce different reasoning branches?
The framework employs a consensus-based voting mechanism. Only validated reasoning branches contribute to the vote, while invalidated ones are abstained. If consensus is not reached, the framework initiates a new reasoning round, incorporating feedback from the thought validator to refine the next iteration.
So the thought validator agent plays a crucial role in ensuring the reliability of the final answer. Can you elaborate on the benefits of this approach?
The thought validator agent significantly enhances the trustworthiness of the final answer by eliminating flawed reasoning paths before they can impact the outcome. This approach allows for both exploration of the problem space and increased reliability of the answers.
The paper mentions that the framework was evaluated on the GSM-8K dataset. What are the key findings of the experimental results?
The experimental results on the GSM-8K dataset demonstrate that the proposed framework outperforms existing techniques, including standard input-output prompting, chain of thought prompting, and the original ToT strategy. The framework achieved an average improvement of 5.6% across 4 different LLMs.
That's a significant improvement. Can you elaborate on the specific improvements observed in the experimental results?
The framework showed a notable improvement in accuracy, particularly for complex arithmetic reasoning tasks. This suggests that the combination of ToT and the thought validator agent effectively addresses the challenges posed by complex reasoning problems.
The paper also mentions some limitations of the current approach. What are the key challenges that need to be addressed in future research?
One key challenge is the lack of dynamic exploration in the search space. The current ToT method employs a fixed width and depth for the tree structure, which may not be optimal for all problems. Future research could explore more adaptive and dynamic exploration strategies.
Another limitation mentioned is the computational cost. How can this be addressed in future work?
The computational cost is a significant concern, particularly for large-scale applications. Future research could explore more efficient implementations of the ToT strategy or investigate alternative validation mechanisms that are less computationally demanding.
The paper also discusses the social impact of this research. What are the potential implications of this work for the development and deployment of LLMs?
This research has the potential to lead to more trustworthy and reliable AI applications, particularly in domains where reasoning is crucial. However, it also raises ethical considerations regarding the deployment of highly autonomous reasoning systems. It is essential to carefully manage the use of such systems to avoid over-reliance on AI and ensure that human oversight and accountability remain integral to decision-making processes.
This is a very important point. The paper highlights the need for careful consideration of the ethical implications of this research. Can you elaborate on the potential risks associated with the deployment of these advanced reasoning systems?
One potential risk is the amplification of biases through algorithmic decision-making. It is crucial to ensure that these systems are trained on diverse and representative data to mitigate the risk of bias. Another concern is the potential replacement of human expertise in fields where nuanced judgment is required. It is important to strike a balance between leveraging the capabilities of these systems and preserving the role of human judgment and expertise.
To wrap up, can you summarize the key contributions of this paper?
This paper introduces a novel approach to improving LLM reasoning by combining the ToT strategy with a multi-agent framework enhanced by a Thought Validator agent. The framework addresses key limitations in existing reasoning strategies by enabling a more systematic exploration of reasoning paths while simultaneously improving the reliability of generated solutions. Experimental results demonstrate that the approach outperforms state-of-the-art methods, particularly for complex arithmetic reasoning tasks.
This was a very insightful discussion on the technical aspects of this paper. Thank you for sharing your expertise.